Welcome back. Have you ever imported a new dataset and later realized that the dates were all wrong? Duplicates were everywhere and column names were just all over the place? That is where EDA saves you. I'm going to talk about what EDA is, what schema drift is, and how you can overcome these issues as you are importing and examining a new dataset. Let's jump. All right, let me tell you about a project that I did early on in my career. It was probably maybe fourth project in, and I was importing data from this workforce management tool going back like 3 years. And every week there was a new file that was submitted, and I had to import all the historical data for the previous 3 years, and there were 5 different files. And so the the manager over the department said these files are all have always been the same for as long as I've been here. All the columns are the same, the data's the same from month to month, so it should be easy, right? Famous last words. It should be easy and things don't change. If you ever hear from a stakeholder or from a manager that they swear up and down that things haven't changed and won't change, just know that things have changed and they will change. I used the last of each of the file types as kind of my basis for creating the tables and setting up the tables in the database. And so I did that and then started doing the load process, the extract and load. And as I was doing that, the first couple months of each file type went in very smoothly, no problem. But then I would hit like the third, fourth month in, and all of a sudden things started changing. In one file, somebody had put in an explanation point for some reason in one of the column headers, threw things off. In one file, from month to month, I started seeing that columns would appear and disappear. In one file, somebody had created a pivot table and saved it over the existing data and removed the existing data. So these types of things happen. So what we're going to talk about today is how to handle these situations up front and identify all those issues before you start your process as you're doing kind of your discovery sessions. So let's jump in, and we're going to talk about the importance of EDA in data engineering. All right, so one of the big things that you do as a data engineer is you have a new data set that you need to ingest. You're having to import historical data. Sometimes it's the last several months, sometimes it's several years. And so sometimes you're getting, individual files on a monthly basis, and you may have, hundreds of files that you're importing for the historical data for your project. So when dealing with all this historical data, you can't just blindly dump everything into a table and hope for the best. Kind of like what I just talked about with that last project. With that project I just talked about, think of it like trying to combine 5 or 6 years of tax forms where the government has changed the format every year. Column names change, fields go missing, and before you know it, your queries just don't work. Things start breaking left and right. Your ETL pipelines just don't work because columns are missing, columns are added, data's missing, data types are different. Things just change. And that change is called schema drift. So schemas drift, and it's, very much what it sounds like. You have an original schema, and things kind of change over time. It drifts away from what the original schema and what the original structure of that data looked like. So you might be asking yourself at this point, Chris, you said we're going to talk about EDA. So let's talk about EDA real quick. What is EDA? EDA is exploratory data analysis. So one of the first things that you're going to do when you are introduced to a new project that is new data that you're ingesting is you're going to do some exploratory data analysis, or EDA, on that data. You want to understand what that data is. You want to understand how you're going to have to clean it. What types of irregularities are there in the data? What types of data is missing? So EDA is extraordinarily important for a data engineer, not just for analysts and scientists. So that's why EDA isn't optional. It is critical for a data engineer to get these things right up front so that those downstream people, your scientists and your analysts, have the right data types, and whole accurate data to do their analysis and their predictions off of. So next we're going to talk about what is schema drift and get a little bit more detailed as to what happens there. All right, schema drift again happens when the structure of your data changes over time, whether it's new columns, removed fields, or even different data types for the same column. If it's like if your favorite coffee shop kept changing their menu and renaming items. Today's latte is tomorrow's espresso with milk. So, just keep in mind that those things change over time. Different people come in, different managers, different leaders come in, and all of a sudden something's important to the business that wasn't before, or vice versa. And so you have to keep an eye out for those types of schema changes. So I'm going to show you some examples here in a moment, and we're going to walk through a real life example. But let me talk real quickly to you about why this is schema drift and identifying schema drift is so important. If an important column is missing in some of the older files, you have to determine and to have that discussion with your stakeholders. Do you backfill it with some type of default values? Do you leave it null? Do you take an average or median? What does that look like? And how does it best represent that data to your stakeholders? Also, if a column name changed, do you want to rename it? Do you want to create a mapping to where that old field name maps to this new field name? Do you want to just have everything go to the new field name? Do you want to maybe revert back to the old field name? Maybe they didn't mean to change it. So have those discussions, and don't have those discussions in a silo. Have these discussions with your stakeholders. If a data type shifted, it might have been, incidental. It may not have been on purpose. So how do you standardize that? How do you make sure that the data type shift is accurate? And how do you make sure the precision that you hold in your data is the precision that the business needs to make decisions? All right, next we're going to talk about why schema drift is a nightmare, and I am going to give you a walkthrough about how to identify schema drift using Excel. Let me show you the manual way that I have done, and many people do, handle this. It's like filling out a tax form where every year, something's a little bit different about the tax form, right? Some tax rule has changed, some new field, some piece of information that they want is different. 1 year total income is on page 1, the next year's on page 3, and now all of a sudden they're asking for my crypto gains that I'm not even investing in crypto, so why are they even asking about that? So, why do they ask for that? Anyways, if you don't catch these changes up front, it really spells disaster, both for your taxes as well as for your data integrations. So important you catch discrepancies up front and handle them right. So doing this in Excel, it works great, especially when you just have a handful of files that we're looking at. You could easily compare, and especially if there's just a handful of columns, right? Easily compare from one to the other, what's missing, what's not there, what is there. And I'm going to show you a couple ways to do that in Excel here. So again, Excel is an important thing to learn to use. It is something that you could use for EDA. And after this, I'm going to show you a much more automated and a little bit quicker, but programmatic, maybe a little bit more technical way to do this, and even give you a free script and tell you where that free script is that you could go out and get. So let's take a look at these 4 files. So we have our 4 sales files going from 2020 through 2023, and we could kind of see, I've got it laid out here where we could kind of see from, okay, in 2021, we have the customer age and customer gender. In 2020, we don't. We have those columns, but there's no data. In 2022, we do have the columns and the data. And in 2023, we have columns and data. So 2020 is the only year that we're missing here. I do have another 2019 file, and it's similar in the 2019 file where the columns are there and there's no data. But we it's hard, maybe a little bit hard to tell in this format from file to file what maybe column is missing, what field is missing from one file to the next. So let me show you how you can do that. Generally, when I'm using Excel, I've got a file over here that I've already set up for demonstration purposes. I'll take and kind of put the name of the file out to the left and then list all the, copy and paste the column headers from each of those files out so that I could see easily, do we at least have the same number of columns? And we see we have the same number of columns, and if we could kind of glance through here, okay, which ones are there for all of them, which ones are different. And the big thing here that we see is that we have date sold for two of them, for three of the files, and sales date for one of the files. And so there is one other difference, and I'll show you here in a minute. But then what I normally do is you could copy and paste this, right, and transpose it. So you could kind of reverse the layout of how they're pasted, and you just copy, and then you use this little transpose, and it'll put them in a different format and a little bit easier to read, right, and a little bit easier to compare. And so we could say equals this and equals this, oops, and not put a square bracket in there, and we could see that that's true. And we could even say, okay, does it equal here? So it doesn't go more than 2, right? So you kind of have to compare them a couple at a time. But the big thing is we could kind of glance through here and see, okay, they're the same. This is different. Let's highlight that. Total amount, we're good. Customer email, discount applied, payment method, shipping address, billing address. And we could kind of glance down through here and see if anything's different, misspelled, weird characters, anything like that that's going on here that may cause issues during our ETL or ELT processes. So during our extract and load into our endpoint, into our database. So that's how you kind of can do it in Excel. Again, 4 or 5 files, you're good. If you have hundreds of files, it's next to impossible to do it this way, right? There's just no way. In a handful of files, you can do it pretty quickly, glance down through there, and pretty accurately determine what's changed and what's different from file to file. But if you need to look at hundreds of files because you're ingesting several years worth of history that's maybe come through weekly or monthly, then really this is not the most efficient way. But it is a way to do it when you just have a handful of files that you're comparing. This manual approach, I've spent days on when I've had, again, several years worth of files that I was having to compare. But what I learned as I moved through my career is that there are much easier programmatic ways that you could use to do this kind of exploratory data analysis and identify these inconsistencies. So next, that's what we're going to walk through, is I'm going to show you a Pythonic way to walk through these files and quickly give you an answer as to what fields are consistent, what fields are not, and to be able to see what those inconsistencies look like. Okay, before I show you the automated solution that I came up with, I'm curious. Have you ever had to deal with schema changes in your data sets already? Let me know down below, what is your worst data horror story that you've come up with to date? And I will share the top 3 of those in my next video. All right, now let's talk about how you could save time on doing your EDA and identifying schema drift. So I've built this Python script to help you to be able to give you some time back in your life when you're doing these processes, and to speed up your production time and impress your bosses. So here we have three libraries that we're using. We're using OS, Glob, and Pandas. OS and Glob are there to be able to identify the directories that our files are in and to read those directories and give us a list of the file names that are in the directory. Pandas is there to actually do the heavy lifting here. You could also use polars, especially for some of your larger data sets, but since a lot of you may already be familiar with Pandas, we're going to use Pandas today. So very familiar, very similar to how you would do it with polars. But so we're creating a function called detect schema drift. That detect schema drift function is going to accept a parameter called file paths. And again, we're going to use that glob down below, and I'm going to show you how to use the glob to provide it a directory and return back a list of files that are in that directory. And that list of files, that's what's being fed into this function here. So we're creating first a dictionary. So we're creating this schema dict, right? And you create dictionaries using curly brackets. If you have missed some of our other Python tutorials, be sure to go out and check those out. We have several Python tutorials, one of which is Python data structures. And so data structures are, what a dictionary is a type of data structure. In this particular video down here, we walk through all the different data structures that you could create in Python and kind of what the differences are. So if you missed that, be sure to go back and check that out. Okay, so next we're creating a loop. Again, loops are something that we talked about in some of our previous Python videos. Be sure to check out that list of Python tutorials if you've missed them. All right, we're creating a loop saying for each file that's in the file paths list, we're going to create a data frame, and we're going to read the CSV. So PD just stands for pandas, pd.read CSV. There's also read XLS or read Parquet or read any number of different file types. Here we're using CSVs. So read CSV, we're feeding it the file name. We're creating a schema dict of our file. So we're creating a set of the column names that got created in that data frame from that CSV that it's reading. And then we're going to do this describe. So what describe does is it kind of gives us different statistics about our data set. It will give you some averages and some medians and the count of populated, kind of like a count A, like you do in Excel, of for each column. And then we're going to say all columns equals set.union and schemadict.values. And what that's going to do is it's going to union all those sets together, right? All those sets of columns for that schema dict, we're going to union all of them together. We're going to do a schema comparison. And so pd.dataframe, we're going to say the index is the file paths, the columns equals sorted all columns. And then for file on columns in each of those items that are in that schema dict, it's going to tell us for each of those columns, is it present or is it not? And it's going to print out kind of graphically how each of those files compare to each other. And then it's going to return that schema comparison. So let's take a look at what that does before we jump into the dynamically standardized schemas. So yeah, so that's a good hint here. We are going to, after we identify what the variances are, I'm going to show you what this function is to dynamically standardize the schema so that you could put all of that data into one file that you could push into your database or your data warehouse. All right, so let's take a look. We've got, again, I talked about that we're using the glob to give it a, basically we're giving it a file path, right? And for those of you that don't know, I am using Windows Computer, but in Python, if you use the backslashes instead of the forward slashes, then you have to escape them out or use R to let it know that that it's a file path. But in this case, you could also just use the forward slashes. So just a hint that you could use forward slashes in Python when you're identifying different things. So we're also using a wildcard here because each of our files are named sales and then underscore the year underscore complex .csv. So we're saying sales asterisk complex to let it know that I just want to look at these sales complex files that are in this particular directory. So it's going to create a list of those files that are there that follow that pattern. And then we're going to create a schema drift data frame. And that is going to be what gets returned back from our detect schema drift function, right? And we're feeding it, again, that list of file paths that gets created in this with this glop function. Then we're going to print that schema drift and we're going to save it to Excel. Just like I mentioned, you could read from, read CSV or read Excel or read Parquet. You could also do to those same file types. And we gave it a directory to save it out to, and we're going to name this to because I ran this once already just to test it. So we're going to run this. We're going to see that it runs pretty quickly. And we see the green check marks and the red X's. Now, you kind of see here why I am exporting it to Excel 2. Graphically, in the terminal, it really kind of gets confusing because the column headers don't exactly line up with the checks and the X's, but you do see that the checks and the green checks and the red X's. And you see that it gave us 5 rows and 23 columns. So we know that there are 23 columns total. There are 5 different files that it read. And let's go out and take a look at that result. Give me just a moment while I get to it. All right, so what we see here, and I'll scroll over. What we see here is we see the names of each of our files, right? We're gonna make this a little bit smaller. Well, we'll make it a little bit bigger, I guess. We see the names of each of our files through there. We're gonna shrink this a little bit so that we can kind of scroll over. And I'm going to freeze my headers here, freeze my panes here so we could scroll. Okay, so we see everybody has a billing address. They all have these columns. Then we see the date sold. We know from our Excel EDA that some of the columns have date sold and some of them have, what was it? Sales date. So some of the files have sales date, some of them have date sold. We see that 2019 and 2020 have date sold. I mean, probably have sales date instead of date sold, and doesn't have date sold. So as we scroll down through here, we will see that a lot of them are there, and we see that for sales date, we have 2019 and 2020, it called it sales date, and for the rest of them, it called it the date sold. So we see that the X's for those columns. If there were any other columns that maybe were mismatched, you would also see that here, but these are the ones that are different between those 5 files. So super cool, real easy to see kind of where your gaps are, what the schema drift may look like. Now let's go back to our Python and see what we did wrong with our describe. So what did we do wrong with the describe? We did df.describe, but we're not printing it anywhere. We're not returning it. So let's do this. We're going to say print df.describe, and this way it'll print out that when we run it. So let's run it again. We'll just change this so that there's not any conflicts and run this again. And here in a second, you see, now we see all of our describe results. And so we see the count for each of these fields down through here. We see that, this file for customer age and customer gender, there aren't any fields. customer age and gender for 2020 didn't have any age or gender, but the rest of them do have age, right? We see customer age down through here, and it gives us that we have 1,000 records for each of these files. That's what I put in each of the files. So so anywhere where we see zeros, there's a problem, right? Customer email and discount applied, we don't have any. Discount applied here, we don't have any. And so we kind of see some descriptions of, those different data sets. Again, we talked about it gives you some statistics around the mean and some averages at 25%, 50%, 75% for things like order IDs, which don't make sense, but it sees it as a number, so it gives you some statistics around it. Customer IDs aren't, again, they look like numbers, but they're not numbers, and you know that, but those are things that that Python doesn't necessarily understand. The total amount, this is valid, right? Understanding the mean and the standard deviation, the min, min max, and this way you can kind of identify, are there some outliers that you may need to address, may need to look at? Did somebody fat finger an extra zero in a number somewhere, and all of a sudden a customer that may have been, sold something for $100,000 accidentally got sold it for $1 million, accidentally paid $1 million. So things like that. Again, customer age, average customer age, median customer age, things like that. Tax amount. Important things to know as you're kind of looking at that data, again, to identify, is there any outliers that you need to address as you're importing that data. And again, you see down here our schema drift information. So super cool, gives you some statistics, gives you some information there. But let's talk real quickly about this dynamically standardized the schema, right? So again, we are creating a set of all the columns. So we're just creating an empty set here. Again, it's taking the file paths as the parameter. And then we're doing a loop for each of the file paths. Again, reading in the CSV. We're doing an all columns.update df columns. So this collects all of the unique column names. We're converting it to a sorted list. So we're doing the standard schema, sorted all columns. And then we're saying for file and file paths, read the CSV, read the file. We're going to remap, right? Rename mapping. This is where you might you might be able to adjust things on your side, right? As you do your EDA, as you do some of your schema drift analysis, identifying those fields that may be the same that just got renamed, and you can provide that dictionary of renaming examples here. Just if you have multiple, then you just separate it by comma, and you could just keep on adding the different mappings. So in this case, we're going to change the sales date to date sold so that everything is standard across those data sets. This is where it's going to rename based on that mapping. This is where we are looping through each of the columns to ensure that all the columns exist and fill in missing fields with the word none, and then or with nulls. And then we are going to ensure the correct column order based on that standard schema. And then if order ID is in that column, then it's going to make sure that it's converted to a string, things like that. So again, some of this you may need to customize for your specific use case. And there's some customizations that you could add in here. But if you just want all the columns for all the different files, then this will do that. This will read all those files and give you a finalized data set that has every column in it, regardless of whether or not those columns are in every file. And sometimes that's what you want. And sometimes, especially when you're just pushing things into a staging table, getting them into that staging table is what you need to do. So this will give you a finalized data set with everything all together. So again, we have this concatenate function that is going through and concatenating all of the data frames into one data frame with our standardized data frames here that we've appended. Okay, so let's uncomment out our cleaned dynamic data. We're going to just comment out the rest of this that we already ran. And there are two ways to comment in Python. One is your hash, so your # or your hash, and the other is 3 double quotes with 3 double quotes ending your comment section. So again, we are going to dynamically detect schema and standardize the data. And let's run this and see what we've got. Oh, we need to take our file paths out of here so that it still creates that file path. Okay, so ran super quick. Oh, it's running now. It'll take a minute. It's going to put it here. Oh, no, that's where my Python lives. So it is going to, put it here. I'm just going to paste that over into my directory, and you see that it's completed. And let's open up that cleaned dynamic data. And you see that it changed our column to date sold, and we could add a filter and see that everything has a date sold. Discount applied, we see that some are blank and some of them have a discount applied. Again, we noticed that doing our schema drift that that was blank in some of them, right? We have some information here. Everything's all in one place now, a little bit quicker than manually doing it in Excel or some other. All right, let me answer a few of the questions that you may have at this point. Will this work for large files? Absolutely. This is set up using pandas. It will work for files that are maybe Parquet, or will work for CSV files that have millions of records in them. No issue. You may at some point need to adjust this to where instead of reading from CSV, you want to extend it to using Parquet or some other file format, Arrow or something else. And so you could do that by easily just changing that read CSV to read Parquet or whatever file format that you need to read it. You could even add some if statements in there so that it looks at and identifies, okay, if it's a CSV, then do read CSV, and if it's Parquet, then read Parquet. And you might even run into such situations where you have some mixed formats and you'll want to use that if statement to be able to process all of them. What if the names are completely different? You can definitely extend this, especially as you continue your career and learn more, to include some fuzzy matching, right? And suggest some possible renamed columns. So I would love to see other people take this, extend it, and make it your own. I'd love to see what you come up with. Now, final question that you may be asking yourself, can it handle different file formats? We talked about that a moment ago. Currently, it is set up for CSV, but you can, again, easily extend it for JSON, for Parquet, for Excel, and other file formats that pandas can handle. Remember, proper EDA before importing data really will save you hours of debugging and prevent some critical reporting errors. An ounce of prevention is worth a pound of issues later. So, be sure that you go out to gambledataengineering.com and go out and download these Python scripts so that you too can extend these the way that we kind of were talking about. Thank you so much for watching today. I know it was a little bit longer than our normal videos, but I hope you got something out of it, and I will see you next time. Be sure that you come to our Friday night sessions where we have Friday night live streams, and I'm here to answer any questions that you may have about data engineering. Thank you, and have a great week.